Hello everyone, this is episode 3 of my YouTube channel Explore Math Together, and in this episode we will talk about Leonhard Euler. For me personally, Leonhard Euler is a scientist who is example to all of us as a person who followed his passion in mathematics, or his passion despite the disapproval of his parents and his disability. He still achieved enormous goals in mathematics. Leonhard Euler was born in Switzerland at the age of 13. He already graduated university with his friend Bernoulli. Bernoulli are the families who are very popular in math field because of their enormous contribution to mathematics. So his father wanted him to be a pastor in church. However, he convinced his father to follow his passion, and later by the Queen of Russia and the King of Prussia he graduated in University of St. Petersburg and also in Berlin. At the age of 13, Euler had a very terrible sickness which left him with blind eyes. However, despite his disability, half of his work was done after that. The formula that we see on the board is the Euler Product Formula, one of the most beautiful formulas in mathematical history. The left side of the formula deals with all the sum of numbers, and the right side deals only with primes. This formula is said is a doorway to analytic theory. Later on we will study what is analytic theory itself and how it used to explore wider the Riemann hypothesis. So the formula that we see, the first one is called Riemann zeta functions. Basically what is here, it means the one that we already covered with Euler Product Formula. So as we see, for Riemann zeta function we have this series where s is greater than 1. And later on, how we can explore this formula, we first multiply it by 1 over 2, and we get all the even numbers in this series. Then we continue, we do 1 minus 1 over 2, which means we subtract the first formula from the second. Then we get this one with all the even numbers, because we got rid of all the product of 1 over 2. The same steps goes with 1 over 3, then 1 minus 1 over 3, then we left again with even numbers. So as we saw here, all our numbers in series are all prime numbers, and we constantly get rid of each prime numbers as we go further. So if we keep continuing this, we will be left only with 1, which means the digit no 1. And it will be written as this formula, which means the product of 1 minus 1 over prime number of the zeta function is 1. 1 is the only number that survives. And if we plug 1 to this formula, we will get again the Euler's product formula. So in order to develop more and to see how the Euler's product formula, which is here, again shows us very incredible thing, let's take a look here and put this formula in logarithms. So if we put it in logarithms, we will get this formula, which means the sum of ln of 1 minus p to the power of minus 1. However, we have a formula that is given to us that ln of 1 plus x is this series. We can use this formula and take our 1 minus p to the power of minus 1 as x in this case, and develop this sequence here. As we see, this sequence that starts after 1 over p is all very small. It means it diverges all to 0. So we can just remove this part, and we will be left with only sum of 1 over pi. So this means if we want this formula to diverge, it means that the sum of 1 over pi should be infinity. If we want it to diverge to infinity, and here we again prove that the prime numbers are infinite, as we talked about in the previous video about Euclid, how Euclid proved that the prime numbers are infinite. We can also deduce the same from Euler's product formula. Very incredible thing. So let us see how it also connects to Riemann hypothesis. As we already saw that the Riemann zeta function is equals to sum of 1 over n to the power of s, and as we discovered all here, it is for s is greater than 1. But in Riemann hypothesis, in this case, we assume that s is equal to complex numbers, which I showed here. So in this case, the sum of all non-trivial zeros, which means the sum of all non-negative even integers. It's more complicated when we involve complex numbers, so we will delve into it in the next episodes, and we will see how also other great mathematicians made an effort to solve Riemann hypothesis, and how far are we now to solve this hypothesis. So guys, thank you very much. In next episodes, we will talk more about this, and we will also try to explore other hypotheses such as Fermat last theorem and a lot more.